Oh, so thanks very much for attending this webinar. So this webinar is about how you get data between production systems and enterprise systems, whilst also getting through the cybersecurity firewalls and preserving the cybersecurity standards. About the software that we'll be looking at later on in this presentation, the KEPServer, the Cogent, and the OPC router software, you can download and trial all of them free of charge. They'll all have a runtime of between 1 or 2 hours, so you can run it and check it out that really works for you during a 1 hour, 2 hour period. And then after that period has lapsed, you can then stop and start it again. If you want to do a proper soak test, then you can give us a call and we'll provide a 30-day trial license so you can do a proper soak test. A brief look through the agenda itself. We'll be looking through the topology, looking at the requirements of the two networks, the DMZs, the protocols used across the OT to IT interface, and then looking at some examples of the ways you can, topologies you can use when various firewalls or ports are open or closed. And then we'll look at some real-world examples later on where real-world situations where the products themselves are being combined to solve these problems. A little bit about M.A.C. We're a leading technical distributor of industrial IT and OT technical equipment. But we're not just a reseller. We're not a box shifting wholesaler. We've got technical expertise in the realms of industrial IT and OT, and we're part of the Pantech group, which includes Solutions PT. And across Solutions PT and M.A.C, we have a cyber team who are experienced cyber professionals. And those guys can also be a further resource for you if you want to look into this subject in a deeper way. We deal with customers all across the UK, end user manufacturers, systems integrators, and machine manufacturers as well. So we have a very broad church of customers. But this webinar is mostly aimed at end users who have this need to get data between the enterprise systems and the shop floor. So let's have a look at the topology overview next. So we're looking at the two different parts of the solution. You have the IT network at the top. You have the OT network below it. And you need the data to come from the production areas into the business systems for a manufacturer to run a maximum efficiency. Which means obviously the data needs to traverse this interface between the OT networks and the IT networks. So what are the requirements of that interface between the IT systems and the OT systems? Well, the OT systems are responsible for gathering the data from the production devices and providing that data upwards to the IT systems. And the IT systems are responsible for consuming that data, and both the provision from the OT system up and the consumption from the IT system down must be using an interface that's compatible with the other side. Secondly, let's look at the cyber requirements from the perspective of the IT side and the OT side as well. So from the IT side, the IT firewall is there to protect the network from external attacks, including attacks from the OT network upwards. So any proposed solution can't compromise the level of protection provided by that firewall. A proven established approach, and one which is recommended by various authorities, and which we'll come into later, is to keep all the inbound ports closed in that firewall, so not allow sessions connecting from the outside in. So only sessions initiated from the inside out are allowed. So that's okay. Outbound is okay. Inbound is not allowed. From the OT side, you have a similar situation, but almost flipped on its head. The OT firewall is responsible for protecting the OT network from intrusions from the IT side. And actually, when you look at the figures and reports related to OT intrusions, nearly all of them start from a spear phishing attack or some sort of credentials attack on the IT network, and those that is the way in, so to speak, and that then gravitates down onto the OT side. So protecting the OT firewall is probably more important than protecting the IT firewall, because any hack intrusion is likely to come from the IT network down rather than from the OT network up. So the OT firewall is there to protect the OT network, and again, any solution shouldn't really compromise the level of protection of the OT network. And again, keeping the inbound ports closed on the OT firewall and only allowing sessions initiated from the OT network out. So again, inbound is not allowed, outbound is allowed. And just to hammer home the cyber threat, I was recently looking at a report from a company that specifically is a specialist in America and the ICS, and they've seen a lot of industrial security threats to production systems, more so in the US than many other places. So you'll have seen the US gas pipeline was shut down, Honda was hacked, hackers attacked the water treatment works in Florida, accessing an HMI and overdosing one of the water treatment works with caustic soda, or attempting to. Ransomware attacks are almost doubling in prevalence every single year, and that is a serious threat. You know, locking all the data on all your PCs inside in the production area, that's a very serious threat. And mass data thefts as well. Just in February alone, you can see some of the people that were hacked successfully and which have owned up to being hacked: Vodafone, Maya, Bridgestone, Toyota, and Viasat. And because of this, the American government and also the European directives have come out, and there are now pretty heavy fines for any hacks, especially in regulated or critical industries like power and utilities. So this situation is real. It's not something you can avoid to ignore. It's a very real situation. So how do we overcome the issue of having to keep all the firewall ports closed? So the use of a DMZ is the way to do this, and it bridges and isolates the two systems. So it's both an isolation barrier between the IT systems and the OT systems, and also a bridge between them. All comm sessions are initiated from the OT and IT networks in, and a middleware application is installed. And that middleware application, all the data passes through that middleware application. So only indirect communications is possible between a system on the IT side and a system on the OT side. Plus, the DMZ also provides an extra level of flexibility, because you don't have one firewall, you have two firewalls. It does also allow for a little bit of flexibility in terms of the rigid rules of only outbound ports allowed. It is possible in one of the firewalls to open up an inbound port to allow a protocol to go through, if that protocol is known to be very secure. And we'll look at the security of the various protocols that you used across the IT, OT, DMZ in a little while. So here's the first protocol, OPCUA, and it's very, very secure. It's got public-private key encryption in both directions. It complies to international standards, so it uses RSA, TLS, SSL, all of the international standards for encryption and authentication. The OPC standard has been around since 2005. The OPC Foundation's been around for more than 25 years now. And the OPC client initiates the comms session to the OPC server. So here you have an OPC server, here you have an OPC client. Before the comms session is initiated, during the configuration of the link between these two machines, the client shares the public encryption key with the server, and the server shares its public encryption key with the client. So that's before any comms is started. That's part of the configuration. And you can see there you actually have key encryption in both directions. Now, if you're doing online banking or interacting with a secure website, you only have encryption in one direction. So this is twice as secure as doing a standard secure session using your browser. So once configuration is done, the client can then initiate a session with the server. And once that session is initiated from client to server, you can then get two-way data flow. So that's OPCUA. MQTT. MQTT is a publish, subscribe delivery mechanism for transporting data values and data statuses between systems. It's bidirectional. We're only really looking at one direction in the diagram below, but it will go in both directions. It uses SSL and TLS encryption. It's been around for quite a few years. It was originally an IBM standard invented in 1999. It supports data buffering, which is interesting. So if you have situations whereby you have network outages, it's possible to use MQTT to do a store and forward type function. And the publishers and subscribers initiate the comms to the broker. So at the center of the solution, you have an MQTT broker. And that can be a cloud-based broker, because all of the IoT cloud systems provide an MQTT broker as part of their services. It can also be on-premise. So the Cogent Data Hub, for instance, you can buy an MQTT broker for the Cogent Data Hub. The publisher publishes the data. It's the provider of the data. And the subscriber is the consumer of the data. So the subscribers make a connection to the broker. They subscribe to the data that will be coming at some point from this publisher. So that they say, we're interested in the values coming from that particular entity. When the publisher then sends a value, the broker then informs the subscribers. So that's the MQTT protocol and how it's put together. REST. Now, you'll have all heard of REST, but it's not actually a protocol. It's more like a style of communication, and it's often associated with REST APIs. So, for instance, when you're using your browser to connect to a website, you are using a REST client, your browser, to connect to a web API in the web server system. It runs over a client-server architecture. Your browser is the client, the web server is the server. You're using a format of data called JSON, which is a structured value pair type of arrangement of data. And each request is a separate request. They're not connected to any other request. So with an industrial interaction, when you might be asking for a value of an item, you'll typically get the tag ID, you'll get the value, you'll get the quality, and you'll get the timestamp. Very much the same sort of data you would expect to get from an OPC tag. You can get through the same type of interactions using RESTful communications. Commonly, it's used over HTTP, or more commonly now HTTPS, the secure version, and it does support data buffering. So your REST client can store the data. And if you have network outages, instead of having data holes, the data will be uploaded in a larger chunk when the network comes back. And as with the example of your browser connecting to a server, the client initiates comms to the server. So there's your REST server, there's your REST client. The session is initiated from the client to the server, and then instructions can be done to get data in both directions. So a get would be the client asking data from the server. A put would be the client providing data to the server. Now, DHTP is a bit of a specialist protocol that was designed by the Cogent Data Hub people. They did this back in 2000, and they did this in order to overcome issues of getting data, mostly OPC-DA data at that time across networks. It's a data mirror protocol, so you create a network of data hub tunnel masters and slaves, and once you set that system up, all the data across all the nodes is shared with all the other nodes. It uses the HTTPS encryption, the 256-bit encryption, and you can use your own certificate, or you can use the certificate provided by the product itself. It was, as I say, purpose-built for tunneling OPC-DA data, but you can also use it for tunneling OPCUA data, but also OPC alarms and events, alarms and conditions. You can even tunnel Excel data, and you can also handle logged data. So you can do a store and forward and tunnel of log data. So that's particularly useful. The arrangement is that the Data Hub Tunneling Protocol slave initiates the comms to the master. So you have your slave, you have your master. The master shares the public key to the slave, and therefore the slave knows it's connecting to the correct master. Once that is done during the configuration phase, you can then initiate a session from the slave to the master, and the data can then be sent in both directions. So it's a two-way real-time data mirror. So having looked at the protocols, what are the implications of using those protocols on the topology we looked at earlier, which involves the firewalls? So if you're looking from the perspective of the firewall on the OT side, an OPCUA session, the client is connecting inbounds to the server. Now the server would reside on the OT side, on level 3 as in this diagram here. So the OPC client is trying to get in through an inbound port, which we looked at earlier, ideally should be kept closed. If we look at MQTT and REST, those are both initiating from the REST client up or the MQTT publisher up. So from the perspective of the OT firewall, these are outbound ports, so that's perfectly fine. The Data Hub Tunneling Protocol, if you install a slave on the level 3 OT network here, again, it's making an outbound port. So that's acceptable in terms of the firewall. Hence, OPCUA is the only protocol from the OT side where you need an inbound port. But as we looked at before, OPCUA uses public-private key encryption in both directions, so it's very secure. Let's look at the same protocols from the perspective of the IT firewall. The IT firewall is there to protect from inbound connections. OPC doesn't require an inbound connection. It's the client is connecting down to the server. The client is the consumer of the data, and the server below is the provider of the data. So that's fine. It needs an outbound port from the perspective of the IT firewall. The MQTT session is being published upwards to the server, and the REST client is pushing up to the REST server. So the MQTT broker, sorry, and the REST server. So both of those are needing inbound ports on the IT firewall. The Data Hub Tunneling Protocol, again, if you put the slave on the IT side, then again, it's making an outbound port. So MQTT and REST need inbound ports, and OPCUA and Data Hub Tunneling Protocol do not. So let's look at some topologies where inbound ports are allowed, or an inbound port on the OT firewall is allowed. So we've got a port which is allowed here. You can see that circle around the inbound connection. So to get across the DMZ, you would install an OPC server on the OT side, an OPCUA client on the IT side. You would install a middleware application, and that middleware application, the job of that middleware application is to isolate and bridge between the client at the top and the server below. So this middleware application would act as an OPC server to the client above and act as an OPC client to the servers below. And all of the softwares we sell, the KEPServer, the Cogent, and the OPC router, all of those will do this job of acting as a client and acting as a server. Let's look at a topology where an inbound port is allowed on the IT side. So you can see here we have ports which are allowed into the IT network from the DMZ. So in this situation, you've got MQTT in this example. An MQTT publisher is sitting on the OT side wanting to publish its data upwards. An MQTT broker is sitting on premise, or an MQTT broker is sitting in the cloud waiting to accept that data from the publisher. So you need a middleware application installed in the DMZ, which is acting as a broker to the publisher below, and then a publisher to the brokers above. So again, it's doing this isolating and bridging function. And in terms of the products we sell, the OPC router and the KEPServer will act as MQTT publisher. The Cogent Data Hub will do both. It'll act as a broker and also act as a publisher. From the perspective of using REST, it's a similar picture actually. You have the REST client below that wants to send its data up to the REST server, whether that be on the IT network or whether that be in a cloud. You install a middleware application, which acts as a REST server to the client below and a REST client to the server above. And the KEPServer software will do both. The OPC router will act as a client, and the Cogent will act as a client. So across the various products, we can provide all these types of topologies. Now, the next example is to look at situations where both the IT firewall and the OT firewall have all their ports closed. So, which is the ideal situation for keeping maximum protection from a cyber threat. So, no inbound ports allowed here. The way to achieve this is to install a Data Hub Tunnel Master on the IT side and the OT side, on both sides of the DMZ, and then a DHTP slave application in the middle. So what that will do, it'll act as a connection, a bridge and an isolation between both of those two masters. So the Data Hub Master on one side and the Data Hub Master on the other all the data between them will be automatically mirrored. So anything that changes on the OT side will instantly be mirrored on the IT side and vice versa through this middleman of the DHTP slave. And this is the Cogent product, which is the one here. It's unique in providing this type of mirror approach. So what are the different roles of the software products that we sell? Where do they fit in these topologies, and what uniquely do they do? So KEPServer is at the lower levels, typically for doing the comms to devices. So without a KEPServer server in place, you might have disparate systems on your shop floor, maybe from different vendors talking to different bits of equipment. You won't be seeing the data in all the data in any one particular environment. There's no unified comm structure. And so it's difficult to see a way of creating a unified solution from the OT network up into the IT system, because the data is in different formats across different systems, probably running on different operating systems installed at different times. The job of KEPServer is to stratify and simplify this by connecting to all of the devices on the shop floor in one go. And then from the top interface of KEPServer, you see one version of the truth from everything on the shop floor, whether that's PLCs, drives, energy meters, whatever it may be. And then you have one single interface through which you can get OPCUA data, you can get MQTT data, and you can get REST data through the firewall across the DMZ. A little bit about KEPServer whilst we're here. It's the world's best-selling OPC server. It's legendary for its stability and reliability. You can program it remotely using a web API, so you You don't have to sit in front of the GUI and add all the configuration tags individually. You can do it programmatically through a secure web API. It has various plugins. It has 150 different drivers, more than 150 different drivers. It has 3 user configurable drivers for doing communications to devices that aren't already in the library. And you can do pretty much anything with those, especially the most recently released one, the universal device driver. It has its place in the lower level, talking to all the devices, but also can provide links to IT systems and business systems and cloud systems. In fact, one of the webinars on our YouTube channel is 2 of them actually. 2 webinars on our YouTube channel are connecting the KEPServer software to Microsoft Azure. The role of Cogent Data Hub. The Data Hub product comes from a background of OPC DA tunneling, but it's also grown into a much wider offering in terms of different things it can do. So it can tunnel OPC UA, it'll tunnel OPC DA, alarms and events, it'll tunnel OPC alarms and conditions. It's an MQTT broker and publisher subscriber. It will handle REST. It will take data to and from databases. It has a Modbus driver and it has a scripting engine. So it's a very, very powerful tool for doing multiple things within this type of communications layered solution. And the OPC router, this is a product which has its place in certain applications where it's uniquely skilled to do what you need to do. It lives at the lower level and it has a sequencing and flowcharting engine, so it can do communications on the OT network and allow you to do a sequence of operations between dissimilar systems, perhaps a barcode scanner, then interacting with a database when loading values to a PLC, then completing the task and writing a value back to the database, and then printing a label. So you can see a whole sequence can be driven from the OPC router when it's used down on the shop floor. It also lives at the higher level and communicates to lots of different business systems like IBM Watson, SAP, Amazon Web Services, MindSphere. So it lives in 2 different places, and it has a very nice graphical interface for developing and designing the data flow and also monitoring it when it's running live. So let's have a look at some real world solutions. And these following diagrams are quite busy, so here are some legends to what you'll see in the diagrams rather than be having labels all over them. So here we have an example of using the KEPServer product at multiple places across the network. You would use the KEPServer software to get data from the PLCs at the bottom. And those would be a vast array of drivers, as I mentioned before, over 150 different drivers. And that could be providing data for your local SCADA on the shop floor. And the KEPServer could also be logging data to a local database. So all of those functions live on the OT network. You would then open a port inbound on the OT firewall and put a second copy of KEPServer above. That second copy of KEPServer is acting as an OPC client to the OPC server below, and then acting as an OPC server to the systems above on the IT network. So in 2 hops and 1 open firewall port, you've created a connection from the OT to IT just using the single product KEPServer. And this is a very common solution we see. In fact, it's also possible to put 2 copies of KEPServer down on the OT and have the DMZ copy of KEPServer able to connect to either the duty or the standby, depending upon the status of those 2 redundant pair servers. So you can do lots of different useful topologies using this type of approach. KEPServer also has the ability to push data using REST and MQTT. So it's quite common for people to use the DMZ or even put a 3rd copy of KEPServer up on the IT network to push data out to cloud systems such as Azure and MindSphere and Amazon Web Services. So that's where KEPServer fits and what it can provide. When you combine the KEPServer with the Cogent Data Hub, you have a very powerful combination. the KEPServer getting the data from all the devices, pushing the data locally to local SCADA, then linking using OPCUA to the Cogent Data Hub, where you'd install a slave mode on the OT network. That node of Cogent Data Hub could also do data logging, because both KEPServer and the Data Hub have the ability to log to databases. It would connect inbound to the master node of Data Hub sitting in the DMZ. On the IT side, you would install a second slave mode of Data Hub, which should also connect inbound. And you can see there's no ports outbound here. Both of those firewalls have got all their inbound ports closed. At the top of the slave Data Hub on the IT side, you then get OPCUA. So what you've done in 3 hops here, you've taken the data from the OPC server, KEPServer, and you've made it available to the enterprise systems above, but no ports are opened on either of those 2 firewalls. And of course, because Cogent has other functions as well, you can also push that data to various IoT cloud systems and other things besides. You could log the data up at the IT side as well. So there's lots of things, all the functions of all the products are available at all the levels. You can achieve a similar solution using KEPServer and Cogent using MQTT. So here you have your KEPServer software getting data from the PLCs. It's pushing data locally to an OPCUA client, which is your SCADA. It's pushing data, it's logging data to a database. It can then publish the data to an on-premise MQTT broker, which is the Cogent software. And at the top of that, you can then get your OPCUA data out. So again, you can see there's no ports inbound available here. All the ports inbound are closed. So you're getting the data from the OT network into the IT network, and you're keeping all the ports closed whilst you're doing it. This is a very interesting application, which is some of you on the call here may have legacy OPC-DA systems, and perhaps those are running on Windows XP or Windows 7 or Windows 2000 or one of the really old operating systems. You can, using the Cogent Data Hub software, install a slave mode on those old nodes and do the same thing as we looked at before of creating a 3-way tunnel and get data from those devices also onto the IT networks, again, without any ports open. And if you are in a situation whereby you have OPC-DA systems running down on your OT network, you really, really do need to keep all ports closed on that OT firewall, because OPC-DA uses the DCOM security model from Windows, and that is known to be a very mature known attack vector for hackers. DCOM has got multiple exploits. So keeping that behind a good firewall, or even better, upgrading it to OPCUA if you can, changing that system out, then that is a good solution. But this effectively achieves the same sort of thing, gets the data out, and you can keep all the ports closed. At the same time, obviously, you can then push the data to other places, all the other features that Cogent has. This is a solution combining KEPServer with OPC router. Again, the data from the PLCs into KEPServer, data to the local SCADA, logging to a database, pushing data up to a second copy of KEPServer, and then pushing it up to the OPC router product, which then can be used to integrate with SAP systems, Azure, MindSphere, AWS, IBM Watson, lots of different types of ERPs, lots of different types of databases. It has a very wide range of connections available to it. The OPC router product does. So again, for those type of applications, this is an ideal way of doing that in a method that's designed specifically for it. Okay, so just a brief agenda recap. So we looked at the topology, we looked at DMZs, we looked at the different protocols, we looked at the implications of using those protocols across firewalls, examples of under different situations of which ports are closed and which ports are open on the different firewalls. And then we looked at some real world examples using the products that we sell. So my name is Dave Hammond from M.A.C Solutions. So if you have any questions and queries or after this, please feel free to contact us, and we should be able to help you. We're here at your disposal, and please feel free to contact us when you need us. So thank you very much for your time.